So going further, let's see that how dynamic PAT works. So let's say that you have user 2, user 3 and user 4 who are sitting in the private network of some XYZ corporation. Now here this XYZ corporation, as I said, could be a shopping mall, it could be airport launch, it could be railway station, it could be hostel, etc, etc, right? And let's say we have a Stack Overflow server which is running on a public IP address 128.0.0.1 and a HTTP port number 80. Right? So server application is listening on this IP address and port number. Right? So let's say that user 2 wants to access the Stack Overflow server. Right? So obviously the packet that is generated by the user 2 would have the source IP address equal to its own address. Destination IP address will be the address of the public server which user 2 is trying to access. Source port number is something that is dynamically generated by the operating system of the user 2, right? So I've taken it as 23, and all the magic of the dynamic PAT lies with this source port number, right? And of course the user 2 has to connect to the Stack Overflow application which is running on the port number 80, so destination port number will be 80, and obviously it has to generate a TCP packet because Stack Overflow application is running over TCP protocol. So when this packet crosses the firewall, after translation, what will be the changes in the content of this packet? The source IP address will be changed to the public address 100.0.0.5. Destination IP address remains same. Now firewall will create or generate a new port number. In this case, it has generated a 32, right? And it will insert that new port number in the transport header of the packet, right? Destination port number remains unchanged, protocol remains unchanged. Only entity that is changed is the source IP address and the source port number, right? And firewall keeps a track of this change in a table called translation table. So this table is maintained by the firewall internally. You can see this table on the firewall using the command show axlate. So here you can see that it is keeping a track that the packet whose source address was this has real source port number 23. The source IP address of the packet has been changed to the public address 100.0.0.55, and the source port number of the packet is changed from 23 to 32, right? So remember, 23 was the port number that was dynamically generated by the user 2 machine, whereas 32 is the port number that is dynamically generated by the firewall, right? So this table keeps a track that what packet came and what has changed in the packet after translation. Similarly, when the user 2 and user 3 tries to access the Stack Overflow server, you can see that the firewall has replaced the source port number of the packet with the source port number which it had dynamically generated, right? And obviously the source IP address in all cases will be replaced by the same public IP address. And the entry in the translation table will be done for all the 3 users. So this translation table will help the firewall to actually translate the return traffic from the Stack Overflow server into its original form so that the return packet could be delivered to the right user. We will see in the next slide that how untranslation is performed. So here you can see that untranslation is now very obvious. You can see that user 2 had generated this particular I can say IP packet, right? And firewall had performed a translation over it, and it translated this packet into this packet, and it made an entry into its transition table. Now, when the Stack Overflow replies, obviously it will reply with this packet. It will swap the source and destination IP address of the packet that it had received, and it will swap the source and destination port number also. That is what reply packet is. And when this packet hits the outside interface of this firewall, this packet will undergo untranslation. And you can see that the firewall will now consult this table. in order to replace the destination IP address of the packet and the destination port of the packet with the original IP address and the original port number. So this is untranslation. And once the packet has been recreated into its original form, now internal infrastructure of XYZ Corporation can route this packet based on destination IP address to the correct user, right? So you can see that the source port number, which was randomly generated by the firewall, plays a role in order to identify that how a return traffic from the outside machine needs to be untranslated into an original traffic so that the original packet could be delivered to the right user. So this is how dynamic PAT works. And when we come to the port number, there are thousands of ports number which are supported. For example, 65,000 plus port numbers are there. So you can see that exceptionally large number of users in the private intranet of XYZ Corporation can use or can make use of the same public address, because here it is the port number which is generated by Cisco ASA firewall, which made it possible that hundreds of thousands of users in the private network can access the public services using the same public IP address. So dynamic PAT is relatively very easy to understand as compared to other NAT or PAT schemes. So few points regarding PAT. So dynamic NAT and PAT are unidirectional, right? So dynamic NAT or PAT works only from inside to outside. The communication has to be initiated only by internal user, right? The communication cannot be initiated by the public user. And only one public address is consumed to allow thousands of internal users access public network, and there are 60,000 ports available on firewall to perform dynamic NAT. And the example where dynamic NAT are always in use are malls, airport, hostels, etc., etc., etc.